It's our fourth lecture of FDE EST Physics test preparation. We are covering all the physics past most repeated FDE EST papers, MCQs. By covering these MCQs, we made a complete guideline, a complete manual, a set of all previously repeated FTE, EST, physics MCQs, which are the most important. Okay, by doing these limited and these common MCQs, you easily secure 90% of your test. We also cover pedagogy part as well as the English part in our upcoming videos. In our previous video, we already did 3 lectures of EST physics test in which we cover first 3 chapters thoroughly. In today's lecture, we are going to start with chapter number 4 of FDEST physics test preparation, which are the most relevant and the most repeated MCQs in all the tests yet. So we are supposed to cover all lecture. This is a total 96 pages PDF only for physics. We have papers. We have also other subjects like English and other subjects, relevant subjects like Islamabad, chemistry, biology. Okay, we cover all those lectures similar to like this. If you provide, if you need these lectures physically, we will cover all those lectures in these videos. But if you want those lectures physically, you can just leave a comment below, or you can directly contact with me. I will left my WhatsApp number in the description below. You will directly contact me. I should provide you these valuable PDFs with you in sake of a little price. Okay, so let's start our lecture number 4, which is about the thermodynamics. We will discuss about temperature and heat. So first of all, you must have to know about the temperature scale. What is temperature scale? So temperature scale is basically our systems for measuring temperatures using standard units. So there are some standard units we have from which we measured our temperature scales. Like we have a scale of Celsius, we have a scale of Fahrenheit, and we have a scale of Kelvin. So though these are basically the scales of measuring the temperatures. First of all, you know about what is Celsius. Okay, so Celsius is basically, the definition is the a temperature scale where 0 Celsius is the freezing point of water and 100 Celsius is the boiling point of water at standard atmospheric pressure. So at standard atmospheric pressure, we are using the Celsius scale as 0 degree Celsius as a freezing point of water, and water for water, and 100 degrees Celsius for water is the boiling point. We take these as standard scale for the Celsius at the standard atmospheric pressure, which is the 1 atm pressure normally. What is the usage of Celsius? Widely used around the world, okay, particularly in scientific context. Okay, so next temperature scale is the Fahrenheit scale. Okay, this is another scale to measure the temperature. Okay, a temperature scale where 32 degree Fahrenheit is the freezing point of water and 212 Fahrenheit is the boiling point of water at the standard atmosphere. So you can see there is a difference between these scales. So in Celsius, 0 degree Celsius is taken as the freezing point of water. But in Fahrenheit, you can see 32 Fahrenheit is basically the standard freezing point of the water. Okay. And 212 Fahrenheit, 212 is taken as the boiling point of the water. Okay, boiling point of the water at the standard atmospheric pressure is same. So what is the usage of Fahrenheit? So commonly used in the United States for everyday temperature measurements. So in United States means in USA, America, so the temperature scale is used as the Fahrenheit. Mostly in our countries, Pakistan is we are using Fahrenheit scale to measure the temperature measurements in different cities or countries. Okay, the weather forecast. So this is the difference. So let's check about what is Kelvin. So Kelvin is another temperature scale. So the SI unit of temperature. The definition of Kelvin is the SI unit of temperature. So Kelvin is basically the main SI unit of the temperature, you can say. So if everybody should ask you from what is the unit of the temperature, so you can say the Kelvin is the basic standard SI unit of the temperature, starting from absolute zero. So this starts from the absolute zero. Okay. So what is absolute zero? Where zero Kelvin is starting is the point at which the thermal motion ceases. What is meant by ceases? Thermal motion means there is no motion. So at 0 Kelvin, there is no motion. Let me ask you a question. Uh, is it possible that in our world there is no motion between the subatomic particles? So there is no such a case. This is ideal case. So 0 Kelvin is basically an ideal case. Every body, every particle, every subatomic particle is still vibrating. If this is vibrating, then this is producing some thermal motion. So basically at 0 Kelvin there is no thermal motion. Okay, the thermal motion case is 1 Kelvin is equivalent to 1 degree Celsius. Okay, 1 Kelvin is also equivalent to 1 degree Celsius. So what is the usage? Primarily used in scientific research and the thermodynamics. And what is the formula for the conversion of the Kelvin? So if you want to convert Kelvins into Celsius, so what you have to do? So if you have a value of Celsius and you have to convert it into Kelvin, you just have to add it by 273.15. Okay, so formula to convert Kelvin into Celsius or either Celsius into Kelvin. If the value of Kelvin is mentioned, if you want in Celsius, so you just have to minus by 273.15. So this is the correlation between the Kelvin and the Celsius. Okay, so the starting point of Kelvin is also 0 Kelvin, which is known as the absolute zero. And at absolute zero, your all the motions cases. Okay, so let's start with the MCQs, which is the most repeated past EST physics MCQs. So which temperature scale is primarily used in scientific research as an absolute scale? As I mentioned you before, the only scale which is used as an absolute is the Kelvin. Whereas Celsius, Fahrenheit, Kelvin, all these are the units of the temperature, but the most absolute scale in scientific notation in SI units is the Kelvin. So the temperature of unit of temperature is Kelvin. Okay. What is the freezing point of water in Fahrenheit? You know that the freezing point of water in Fahrenheit is starting from 32. So it is 32 Fahrenheit. Very important. Okay. On the Celsius scale, the boiling point of water. So you know that on Celsius scale, the boiling point of water is at 100 degrees Celsius. So correct answer is 100 degrees Celsius. Now, what is the equivalent of 0 Kelvin, 0 Celsius in Kelvin? So, as I mentioned you before, if there is a relationship to convert Celsius into Kelvin and and Kelvin into Celsius, because Kelvin is equal to Celsius plus 273.15. Okay, sorry. So, if Celsius is 0, so Kelvin must be equals to 273.15. So, the correct answer is answer C. Okay. If the temperature is 77 Fahrenheit, what is in Celsius? So if you want to Celsius, you just have to you need Celsius. So you know that Kelvin is basically equals to what? You know the relationship as I mentioned you before. So there is a relationship conversion of Fahrenheit into Celsius. There is a different formula. Let me show you how you can write. So there is a conversion formula how you can convert. So you can see this is the formula if you want to convert uh, Fahrenheit into Celsius or either Celsius into Fahrenheit. So what if you want to convert Celsius into Fahrenheit? You just have to move this 32 here, so it becomes minus 32. So here you will cancel with this, and this 9 by 5 comes here, and this reciprocal. Mm, so here you have to multiply it by what? Now inverse, so 5 by 9. Okay, so this. So Celsius become equals to this. So this is basically the formula. You can write it as here. So Celsius is equals to this, and Fahrenheit is equals to mentioned above. So this is the formula relationship between, if you want to convert Fahrenheit into Celsius, which is equals to, if Fahrenheit is equals to 9 divided by 5 multiplied by Celsius plus 32, and 9 by 5 is basically 1.8. So if you want, if there is a value of Celsius mentioned, so just put and you get in Fahrenheit. But if the value of Fahrenheit is mentioned, like in this problem, which is 77, so we have to put the value of 77 here. So 77 minus 32 multiplied by 5 by 9, we get answer which is 25. So these two are the formulas. The first formula, you know that the conversion of Celsius to Kelvin. Okay, so Celsius to Kelvin is this formula. Kelvin is equals to Celsius plus 273.15. While if you want to convert your Celsius to Fahrenheit, so this formula you have to use 9 by 5 multiplied by Celsius plus 32. Okay, so this is the formula. Now move further. Which formula correctly converts Fahrenheit to Celsius? So I already mentioned you that if Celsius must be equal, so you have to minus it by 32 and 5 by 9 it becomes, so the correct answer is B. Okay, in Fahrenheit is 9 by 5, but in Celsius it becomes 5 by 9 because we have to take reciprocal. Okay, which of the following statement about Kelvin is true? It starts at the freezing point of water. No. It starts at the boiling point of water. No. It starts at absolute zero. Yes, as I mentioned you before that the Kelvin also starts from the zero Kelvin, which is the absolute zero. Absolute zero, where all your thermal motion is keys. Okay, so its absolute starts from absolute zero. At what temperature do Celsius and Fahrenheit have the same numerical value? This is very conceptual problem. Okay, so at what temperature do the Celsius and Fahrenheit scale have the same numerical value? Okay, so at which value your Celsius and Fahrenheit both have the same numerical value. So you know the expressions of Celsius as well as the Fahrenheit. As I mentioned, these are the formulas of Fahrenheit and Celsius. So if what value of Celsius you put and what value of Fahrenheit you put here to get both answers same. So the answer is minus 40 degrees Celsius. Okay, keep remember this. You can check this by putting value here. If you put Celsius value minus 40 here and Fahrenheit value minus 40 here, you will get the answer of this is minus 40 and this is also minus 40. So numerical value also same minus 40 by putting the value of similar minus 40. Okay, so this at which Celsius and Fahrenheit both gives the same numerical value at minus 40 degrees, minus 40 degree. Okay, so the standard atmospheric boiling point of water in Kelvin. So in Kelvin, you know that the boiling point is how many? In Kelvin, you have to know about that. We know the boiling point of water in Celsius, which is 100 degrees Celsius. And we also know in Fahrenheit, which I mentioned you above, you can see this. In Celsius, it is 100 degrees Celsius. In Fahrenheit, it's 212 degree Fahrenheit. But in Kelvin, I don't know. But I know the relationship between Celsius and Kelvin. If water boils at 100 degrees Celsius, so putting the value of 100 degree, putting the value of Celsius which is 100 degrees Celsius, so 100 plus 273 it becomes 373. So means water boils at 373 kelvins. Understood? So the correct answer here is 373. Option D. Okay. Now, if a substance has a temperature of 310 Kelvin, what is in Celsius? So if you want in Celsius, because you know that Kelvin is equals to Celsius plus 273.15. So if you want Celsius, so it means that Kelvin value minus 273 means 310 minus 273. What it becomes? 20, you can say it becomes 27 plus 10, so it becomes 37, right? 310 minus 273, you will get the value in Celsius. Okay, the same formula, Kelvin equals to Celsius plus 273. So if you want Celsius, so Celsius becomes equals to Kelvin minus 273, and Kelvin value is this. So 310 minus 273 is 37 degrees Celsius. Okay. So now move on towards our next subtopic of today's lecture, which is the thermal expansion. Very important. What is thermal expansion? As the name stands, thermal means heat. So by heating a body expands. This is so called as the thermal expansion, and body expands in their size. Which type of size? Either length, either area, or either volume. Okay, so thermal expansion refers to the increase in size, either length, area, or volume of a material as its temperature increase. Okay, it occurs because particles move faster and tends to occupy more space when they are heated. So when you heat a particle, what it happens? It's occur because particle moves further. Because when you provide heat, the kinetic energy of the molecules increased. As the kinetic energy of the molecules increase, they spread more. And by spreading more, there is an increase in the length as well as area or volume. Understood? So there are many types of expansion. First is linear expansion, which is your body expand in one dimension, only the length expand. The next one is the area expansion. In that your area, this is linear expansion. Next is area expansion. In that your change in the two dimension, because you know area is the 2D meter square. So when there is a two-dimensional change, so you can say area expansion. And the last one is the volume expansion, means if there is a change in three dimension. Okay, so there are some formulas relevant to the linear expansion formula, and there is other formula of the volume expansion formula. Okay, so what is the formula of the linear expansion formula? So the linear expansion formula, in which your length got changed. So the change in length can be denoted by delta L. Okay, delta L basically equals to alpha L naught delta T, whereas alpha is the coefficient of linear expansion. L naught is basically the original length before providing that temperature. After providing temperature, your length got increase, so it becomes del L. Your del L equals to alpha, which is the coefficient of linear expansion. L naught is the original length, while del T is basically the change in temperature. How your temperature change from initial to final. Okay. So this is the formula. So what is the formula of linear expansion? Delta L equals to alpha L naught delta T. Now let's check volume expansion. So what is volume expansion? So the formula of volume expansion is beta V naught delta T, similar. Now beta is your coefficient of volume expansion, while your V naught is the basically the original volume, and delta T is the change in temperature, while your del V is the change in volume after providing heat. Okay, and in that scenario, in that case, your beta is equals to 3 alpha. Means in volume expansion, your it increases three times of your linear expansion. Okay, when you heat body, if there is a volume expansion, you can say there is three times of the linear expansion, because your beta is equal to three times of alpha. This is very important conversion for solids. Keep remember many times these MCQs came. Okay, so now let's check the coefficient of thermal expansion. As I mentioned you, the coefficients of thermal expansions are alpha and beta. So the definition of what is the thermal expansion, coefficients of thermal expansion. So a material specific constant that indicates how much it expands per degree. So this coefficient of expansion based thermal expansion basically depends upon material to material. Every material have their own thermal expansion coefficient. Basically, it describes how much your specific material expands per degree, okay, by change in temperature. And the unit of coefficient of thermal expansion is either per Celsius or per Kelvin. Okay, either it is alpha or it is beta. The unit is per Kelvin or per Celsius. And what are the applications of these thermal coefficients? Are you know that there are some gaps in the railway tracks. Why we left those tracks? Left those small tracks in the railway tracks, because you know that there are climate change in Pakistan. You know there is summer, winter. In summer, your metal got expand. You know that your metal train tracks are made up of metals. So in summer your metal got contract. So that's why we must have to provide some space, because in summer they must have to be expand. If we not provide them space, so they will overlap and your track deforms. If your track deforms, so there are chances of train to have an accident. So that's why we must have some patches of free spaces between those tracks. And because in winter your molecules got contract, that's why we due to that climate change we must have to provide. So these are the applications. In bridges, similar procedure. In bridges we left some space to damage due to the thermal expansion. Thermometers, liquid and gas. Okay, so now move on towards our main MCQs, which are the MCQs from past EST physics test, which are the most repeated MCQs. By doing these, you will got 90% of your score. Okay. So what happens to the most materials when they are heated? They contract, they expand. No, they not contract. We learned that they expand because of the increase in the kinetic energy. So the correct answer is they expand. Okay. Which of the following best describes the coefficient of linear expansion alpha? The change in length per unit length per degree change in temperature. Yes, this is right. Because we know that the alpha is the coefficient of linear expansion. Coefficient of linear expansion. So this is equals to the change in the length per unit length per degree in the temperature, because we know that there is only per degree raise in the coefficient of the thermal expansion. Okay, but there is no change in area. This is the area expansion, and there is no change in volume. If change in volume, then volume expansion. Okay, so the correct answer is A. The change in the length per unit area per unit degree in the temperature. If a metal rod of length L naught is heated, means their initial length is L naught, is heated from a temperature is T1 to T2, and its coefficient of linear expansion is alpha. What is the change in the length L? So there must be some linear expansion. So the linear expansion we know that is equals to alpha L naught delta T. So the correct answer is this, which is the main formula of the. Okay, what is the relationship between the coefficient of volume expansion? We know that beta is equals to 3 times of alpha. Okay, because volume expansion is 3 times of the linear expansion in solids, for solids. Okay, not for liquids. It's mentioned for solids. This is correct. Sorry, not this is 3 times. So the correct one is option C. A material has coefficient of linear expansion 2 multiplies 10 raised to 1 minus 5, If the material is 2 meters long, means initial length is given, which is initial length is given. Okay, you have to use this formula alpha L naught delta T. L naught is 2 meters and alpha is 2 multiplied 10 to minus 5 at 20 degrees Celsius, and what will be its length after 70 degrees Celsius. So temperature changes from 20 degrees Celsius to 70 degrees Celsius, but you have to take the change in temperature delta T. So delta T should be final temperature minus initial temperature, mean 50 degree. So you have to multiply 2 meters multiply by this multiply 50, you get the answer, which is 2.020 meters. The gap left between the sections of concrete bridges is what? Thermal gaps, expansion joints, contraction joints. Yes, those are the expansion joints. Because you know that the in in concrete bridges we left some gaps, and those gaps, as I mentioned before, are due to the expansion joints, because in summer your bond cord expands because they are made up of metals. Okay, expanding objects, metals, or any other expanding material. Which of the following is an application of thermal expansion? Metal expansion in bridge, thermometer calibration, fit of a metal wheel on axle. This all contains metals, so all of above has to be expand. Okay. What is the primary reason for leaving small gaps between the section of metal railway track? To facilitate maintenance? No. To allow for thermal expansion? Yes, we left them to allow in, because in summers they have to expand, so they can easily expand if we left gaps. Okay, so the correct answer is the answer B. Okay, so that's all for this lecture number 4 of FDE EST Physics test preparation, in which we in this video we cover chapter number 4, and in upcoming video we have to cover chapter number 5, which is about waves motions. This is chapter number 5 we will cover in upcoming video. We already uploaded first 3 lectures of this EST physics test preparation. Briefly, this is the end of our lecture number 4, and we will upload more interesting videos regarding this test. First of all, we are covering physics test preparation. That's why for that we have a complete notes of physics FDE EST past almost repeated MCQs. We made it for you easy, and we make a PDF file. This is of total 96 pages. We should cover all these in our upcoming videos. If you can watch those. But if you feel that you have learned physically, so I should provide you these notes. I should left my WhatsApp number in the description below. You can directly contact me by messaging. I will provide you my these notes. Along with that, we have covered biology, chemistry, English, all other subjects, Islamiyat notes similar like this. If you provide those, we will definitely provide you. Just contact me or leave a comment or leave your email below in sake of a little price. Okay. So we will also cover pedagogy MCQs as well as the English based MCQs, because you know that 20% is the pedagogy and 20% is the English based, and the remaining 60% is just subject based. So we will cover all those. Okay, so for that, till now, that's the end of our lecture number 4 of this EST physics preparation. In upcoming video we will discuss about chapter number 5 of this physics EST preparation. These are the most repeated, relevant, and the most unique MCQs which came in the past EST exams. Okay, so till then, don't like to forget and to like and subscribe our YouTube channel. So take care. Allah Hafiz.